What's going on, everyone? Welcome back. Patrick here, and moving on to the next question. We're given a function negative 5x squared plus 20x minus 24, and we got to answer these four parts. So we have to find an equation for the inverse. We have to state the domain and range for the function and the inverse. We have to roughly sketch both of them, and then we have to restrict the domain for the function in order for the inverse to be a function. So very similar to the example before, especially because if you notice we're dealing with a quadratic again. So like I mentioned, what I like to first do whenever I'm given a quadratic is make sure it's in vertex form so I can get that vertex, and it just makes everything easier, at least for me. And in fact, actually, to answer number one, to find the equation for the inverse, which we didn't do in the previous video, you actually have to have a quadratic in vertex form. Because notice, if we don't do that, if we don't put it in vertex form, let's keep it in standard form, and we try to find an equation for the inverse, we interchange the x and y's, and now what? How do we isolate for this y value? That's the next step in finding the equation of the inverse. Notice there's two of them. There's a y squared and a y over here. We can't factor it out because this doesn't have a y. And notice the exponents are different as well. So it's kind of weird, right? So what we got to do is we have to first convert this standard form to vertex form. So let me show you how that works. It's just a little review. So first thing you do is you take out the coefficient in front of the x squared from the first two terms. So if we take out a negative 5, we'd be left with x squared. 20 divided by negative 5 is negative 4. And we'll have an x there. And then the minus 24 we keep on the outside. And now what we do is we take this negative 4 here inside the bracket. We don't take the 20, we take the negative 4. We divide it by 2, and then we square it. So negative 4 divided by 2 is negative 2 to the power of 2 gives us 4. So what we do is we go x squared minus 4x plus 4 minus 4. And then we have the minus 24 on the outside. So this plus 4 minus 4, it's like we're adding 0 there. Those net out to 0. And what we do now is we take out this negative 4 from the bracket, but if we take it out of the bracket, we have to multiply by what's in front. So negative 5 times negative 4 gives us 20. So we'll have positive 20 minus 24 over here. And then this will always be a perfect square trinomial. When we factor it, it ends up being x minus 2 squared. This value is always going to be half of this value, and then this sign is always going to be the same as that sign. And then 20 minus 24, that would give us negative 4. Like that. And I think that is correct. Yeah, it looks good. So this is the vertex form of this. This and this are the same thing. They're the same functions. So now what I'm going to do is I'm going to rewrite this up here. So we got y equals negative 5x minus 2 squared minus 4. And now notice, if we interchange the x and y value, so if we let this be x, this is going to be y. Notice now that there's only one y variable to isolate for. Right? It's going to take a lot of work to get to that y variable, but at least there's one. Versus before, there was two. There was the y squared and the y. We didn't know what to do with that, but now there's only one, and we can isolate for it. And the reason why is because it's in vertex form. So what we can do, we bring the negative 4 over, so we'll have x plus 4 equals negative 5. Then we'll have y minus 2 squared. Divide both sides by negative 5. So these cancel out. And so then what we can do, we have this square here, so we can square root both sides to get rid of that exponent. So we'll have y minus 2 equals the square root of x plus 4 over -5. And actually, if you want to make this look nicer, you could put this -5 as like a 1 over -5. So you could even make it look like this. Make it look a little nicer. And then this -2 you could bring over. Becomes +2. And that's how you isolate for the y value. And so the inverse is basically all of this here. So it's the square root, -1 over 5, x plus 4, and then the +2 is outside of the square root. And you could have also left it in this format inside the square root. You could have also brought the negative up. So you could have put the x plus 4 maybe in brackets, bring the negative up there, make it look a little nicer. So whichever way, this way works as well. Either way, this is the equation of the inverse. But the point I wanted to get across is that if you're dealing with a quadratic and you have to get the equation of the inverse, you got to make sure the quadratic is always in vertex form. And then you could isolate for that y after you interchange the x and y. Right? So that's the answer for number 1. Now number 2, it's asking to state the domain and range for the function and the inverse. And actually what I'm going to do is I'm going to start sketching these. So I'm actually going to jump into part C as well. Now, I'm not going to make a table of values like I did before. In fact, if you have the vertex of the quadratic, so notice the vertex here is +2 and -4. So +2, that's like here, let's say, and then -4 down here. And then notice the a value is negative. And so we know this quadratic is going to be opening down. So this drawing is maybe not as exact as if you made a table of values, but really the most important part is knowing where the vertex is and whether that quadratic is opening up or down. Because now, for the function, I can get the domain, I can get the range. The domain of a quadratic is always what? XER, and the range is YER, but it depends on the y value of the vertex. So notice the y value of the vertex is -4, and it's opening down. So all the y values have to be less than or equal to -4. So that's the domain and range for the function. And now before even graphing the inverse, what do we know? We know the domain and the range for the inverse is just going to be the domain and range for the function interchanged. So notice that the function has a domain of XER, which means the inverse is going to have a range of YER. The range for the function is YER, but y has to be less than or equal to -4, which means the domain for the inverse is going to be XER, and x has to have, or all the x values have to be less than or equal to -4. And we know that if you have a parabola, the inverse of that is always going to be a sideways parabola, as we showed in the previous video. And if we have a sideways parabola and all the x values have to be less than or equal to -4, then we know it's going to be here somewhere. In fact, the vertex of the function is 2 and -4, which means the vertex of the inverse is going to be -4 and 2. So -4, the x value here, and then we got the y value of 2. So that's going to be over here. And all the x values are going to be less than or equal to -4. So it's going to go this way. So that's the rough drawing of the inverse. And notice how I did that without a table of values. All I did was I roughly graphed the function with the vertex and which way it's opening, got the domain and range for it, and then I was able to get the domain and range for the inverse. Right? It was just interchanged with the function. And then from there, with knowing this vertex, I know this vertex is going to be -4 and 2, And I can just sort of play around and see how the inverse is going to look without a table of values. Again, maybe not as precise as with a table of values, but a lot quicker in my opinion. And notice that this and this are reflections of each other on the line y equals x. If we take this and reflect it over this line, we'd end up with that right there. And the point that we have, 2 and negative 4, if you reflect it, you get negative 4 and 2. Right, so we kind of answered number 2 and 3 together. So this is the inverse, and then this here is the function, and then the domain and range for the function and the inverse, respectively. And then number 4, restrict the domain for f of x in order for the inverse to be a function. So notice right now the inverse is not a function. It's failing that vertical line test because there's sort of these two legs here that have multiple y values for single x values. So if we take this x value here, notice it's going to have multiple y values, and that can't happen. So what we can do is we could take out one of these legs. So if we take out this leg, notice now that the inverse is going to be a function. It's going to pass that vertical line test. There's not going to be multiple y values for a single x value. This x value here is now only going to have one y value. But notice now that this doesn't have a range of YER anymore. So we've restricted the range. We said all of the y values, they have to be greater than what? Positive 2. Right? They have to be all greater than or equal to positive 2. Before it was YER because it could be anything. It's going to go on forever. But now all the y values have to be greater than or equal to 2. And so if we restrict the range for the inverse, it means we have to restrict the domain for the function. And so y has to be greater than or equal to 2, which means the function, all the x values have to be greater than or equal to 2. Which means that this leg of the function we would take out. All the x values have to be greater than or equal to 2. So this leg of the function, if we reflect it over the line y equals x, we get this leg of the inverse. And now notice that the inverse is a function. And so that's how we have to restrict the domain for the function. We could have also restricted it by saying all the x values have to be less than or equal to 2. So we could have erased this leg here and kept that other one, which means we would erase this leg and then keep the other one. But either way works. I usually like to restrict the domain for the function where the x values are greater than or equal to something. But you could go the other way as well. And that's pretty much it for this question. So remember, when you get a quadratic and you're dealing with finding the inverse for it, always take that, convert it to vertex form. It's just going to make your life a lot easier.